So we're going to continue with 11.1. We're going to continue talking about limits. We're going to focus more today on the graphs and when limits don't exist. Okay? So here's the problem. Let's say that I give you the function f of x equals, and let's do some piecewise functions today. Makes things a little more interesting because that's when limits can come into play and be a little bit more helpful. So let's say I give you the piecewise function f of x equals 2 when x doesn't equal 3, and f of x equals 0 when x equals 3. We could evaluate this thing numerically, graphically. Algebraically is not going to be an option for this one. Okay? I haven't actually given you the limit yet. Okay? I want you to graph this and use it to evaluate the limit as x tends to three things. As x tends to 0, I want to know what is the limit as x tends to 3. Yeah, it's the same section, but it's different problems. And third, I'd like to know what is f of 3. Okay, so 3 parts to this single question. First, we should probably make a graph or a table to evaluate graphically or numerically. Let's make a graph, just because I want to get you into graphing mode. Okay, so here we go. F of x is supposed to equal 2. How do you graph y equals 2?
Go up 2 for the point and then draw a line.
What kind of a line? Straight line, but where? Like
Horizontal.
horizontal. Okay, perfectly horizontal line. So I'm supposed to equal 2 at all x values except at 3. At the x value of 3, I'm not supposed to equal 2, so I put an open circle at x equals 3. Okay? F of x is supposed to equal 0 at x equals 3. So let's see, I'm supposed to equal 2 all the way till 3, and then at 3, I equal a height of 0, which is down at the x-axis. Okay, and then right after 3, I go back to the height of 2. That's what this function is telling you. All right, so you're graphing y equals 2 for all x values that aren't 3, and you're graphing y equals 0 for the x value of 3 only, which is a point. Okay? Does that make sense or no? Okay, now my question is, what is the limit as x tends to 0 of f of x? Of this function, what's my limit as x tends to 0? So what should I look at on the graph? What does the limit as x tends to 0 of my function ask me to look for on the graph? To evaluate that graphically, what do I need to do? Find the y at the x value of 0, which happens to be on the y-axis. Okay, so you need to evaluate the y value at x equals 0. And what y value is your graph? Approaching 2. Yeah, we've already got it. So f of x, the limit as x tends to 0 of this function is 2. Okay? What's the limit as x tends to 3 of f of x?
Still 2.
Still 2. Okay, you're supposed to look at what's the y value as approaching as x approaches 3. So the y value or height is approaching 2 as the x value approaches 3. Okay, now what is f of 3? What is is it? Big 0. Okay, so sign language back there. Okay. The actual function value is where your graph is drawn. That's different than what is the limit of the function. The limit of the function is what it looks like your graph is approaching, what height your graph is approaching. The actual function value is where is your function located. That's a different question. Okay, because your function is approaching 2, but then it gets bumped briefly down to the y value of 0. Does that make sense? Now, do you see how these are different? If those are different, or if either one doesn't exist, then your graph isn't continuous. So when we tell you that in Algebra 1 and in Algebra 2, when we tell you a graph is continuous if you can draw the whole thing without picking up your pencil, that's true, but it's not really very formal. The formal definition of continuity is that the limit value has to equal the function value at all x values. The limit value has to equal the function value. That means they both have to exist. Okay? But the limit value and the function value have to be the same in order for your graph to be continuous. And that's the first time really that formal calculus is helping you define something that you try to informally define earlier in your math career. Continuity is the first thing you're really going to try to define with calculus. Okay? It takes calculus to make a formal definition of it. Otherwise, you're just going to tell somebody, well, you have to draw it without picking up your pencil. That's not very official. Okay, so that's the first example. Limits. Now let's do another problem. Okay, that was kind of a little bit of a warm-up one, but it kind of got you into graphing. So now I'm going to do another one where you want to graph this. Questions before I erase this? All right, here's the next example. I want to know what's the limit as x tends to 0 of the absolute value of x over x. Now we're just going to do some limit problems. Can you solve that algebraically? Like you did your homework last night if you did it.
Yeah. Actually, I haven't.
There we go. Okay. What does it mean to solve algebraically again?
Plug
it in.
0 for x.
Plug in the value of x that you're approaching for the x value in your function. And you get 0 in the denominator.
You can't have that.
Correct. In fact, you get 0 over 0, which we learned yesterday is called indeterminate form. You need to go further. Okay, and there is a way to algebraically proceed with this a little bit, but the graph or table would actually make a little more sense, I think. Okay, so let's look at this thing graphically because I'm really trying to review graphs with you today. Okay, so the absolute value of x over x. What's the absolute value of x? Tell me how you figure that out.
The distance to x is from 0.
Good. That's a decent way to describe it.
But I don't know what x is.
So, yeah. So how is the value of the absolute value of x different from the value of just x? Huh? There's no negatives. Okay, so on your number line, for all the values that are 0 and positive, the absolute value is equal to your original function, right? For all the values that are negative, your absolute value is opposite your x value. So here's what happens. This is actually the same thing as the piecewise function, okay? Absolute value of x is the same thing as x when x is greater than or equal to 0. Absolute value of x when x is less than 0 has to be opposite of what your actual x value is. Okay, because to get the absolute value, you have to drop the negative, is what we usually say, but you could also take the opposite of a negative. It's like, if you have an x value of -2, to get the absolute value of it, couldn't you take the opposite of -2 to get +2? That's what this negative is telling you to do. It's telling you to take the opposite of the values that are negative. Okay, now, what can we do with that function? X over x. Does that seem like it would be something that would be written in a book? Final answer?
No.
What might you write instead?
One over one.
1 over 1 or just 1, yeah. Okay, so this is the same thing as the function 1 when x is greater than or equal to 0, and this one reduces to -1 when x is less than 0. Okay? Hey, wait a minute. I have a problem right now. At 0, what's my x value going to be? 0. If my x value is 0, what's my function value? Like, should I be including 0 right here?
No, because, well, yes. Yeah, I don't know.
You get a 0 in the denominator. So you can't include 0 with this case or this case, which means you can't include it in your final answer. At 0, this function does not exist. There's an open circle at x equals 0. Okay? So it does not exist at x equals 0. So there's really 3 pieces to this function. One of them is instantaneous at 0. Okay? Now let's graph this. How do I graph y equals 1 when x is greater than 0? How do I graph y equals 1?
Put up 1 and open.
Y equals 1.
Open or close?
Open circle. Good. Open circle, because you're not supposed to include 0 at that, on that domain. Does that make sense? Okay. So how do you graph y equals 1? Straight line. Now, am I supposed to go to the right or the left of that open circle? Right. Good, because x is supposed to be greater than 0. So you're supposed to graph y equals 1 when x is greater than 0. So I should be at a height of 1 to the right of the y-axis, not on the y-axis. Okay. What about, well, to not exist at 0, I should not have any graph happening on the y-axis. Okay. I shouldn't have any marker actually happening there. How do I graph y equals -1 when x is less than 0?
Open circle at -1 and the arrow goes to the left.
Okay, open circle at -1 on the y-axis, and the arrow is going to go to the left. Now we're trying to use this graph to evaluate our limit. Okay, so what is the limit as x tends to 0 of absolute value of x over x equals 0? Well, I probably need to look at my graph, and I need to approach the x value of 0. Where's the x value of 0? On any graph, what's the same thing as the x value? The origin, okay, or the y-axis at least, right? Okay, so this right here is the x value of 0. My graph from the left of the y-axis is following this line right here, and it's approaching what value?
0.
The height, -1, right? From the right side of 0, my height is approaching what value? 1. Is it just that I didn't go close enough to the y-axis? Like, do I need to zoom in or something like that? Are these eventually going to merge?
No.
So what do I say? What's my limit value? It's only 1 on the right side. It's negative 1 on the left side.
The absolute value, no.
Okay, so the limit does not exist. Okay, so this limit, the limit as x approaches 0 of this function does not exist. And we're going to put DNE for does not exist because I don't want to write it out 7 times. The limit does not exist if your graph or function approaches 2 different values. Approaches different values on the left than it does on the right. So a limit does not exist if the function approaches different values on the left than it does on the right. That is one case of the limit not existing. And we generated this graph. The other ones I'll probably graph quickly. I graphed them on Desmos. I'll show you how to do that as well. Okay? All right. Questions so far? Okay. Who are you looking for?
Someone
Okay. They may be on a senior trip. Okay. May I erase this? Any objections? Maybe I should say that. Knowing how to come up with the graph of the absolute value of x and how to write it as a piecewise function is something you need to know how to do for future classes, future class periods in this one, and also future math classes. So the piecewise function from absolute value is kind of important. All right, that's why I wanted to go over graphing that one with you by hand and writing the piecewise function. Okay. So, I'm going to turn on the projector, because now the example I want to work through with you is I want to evaluate what's the limit as x tends to 0 of 1 over x squared. And graphing 1 over x squared can be a little tricky for people. Usually make a table, okay? So evaluate the limit as x approaches 0 of 1 over x squared. It would help a lot if I had a graph. So I've used Desmos, and let me show you how to use Desmos. Okay, so here's what you're going to do. When you go to Desmos, let me show you what the home page looks like. And one of the reasons I asked you earlier if you could download an app for an Android is because they don't have this app for our Windows tablets. So you're just going to have to use the internet. Okay? This is the home page for Desmos, and you go to Launch Calculator. When you launch Calculator, it will give you this cursor over here in a colored box. Okay, and you're going to type an equation, and that equation is going to be probably in y equals form. So you're going to type like y equals, if you wanted to type, let's say y equals x squared. Okay, maybe even 1 over x squared. You're going to use 1, and then you're going to press the division key. Now, on a computer, the division key is the slash, okay, that looks something like this. You probably know that, but I thought I'd say it just in case. They also have a keypad down here you can use if you'd rather. Okay, but we'll go 1 divided by, and notice it automatically puts it in a fraction form for me. That's nice about Desmos. Okay, because now I'm going to be able to see what I'm dividing by, and if you ever want to get out of the denominator, you're going to have to press the over to the right arrow to get out of the denominator. Okay, if I want to divide 1 by x squared, you simply type x, and then you have to raise it to the second power, raise x to the second power. To do that on a computer or on a calculator, sometimes you'll have to look for a caret key, which looks something like this. Okay? So the caret key on my computer is above the 6, and if I press that, I go Shift 6, so that raises me to the exponent. Now maybe you can see, hopefully you can see this on the video. However, it goes x and then it has a superscripted cursor, and I want to raise it to the second power. Ah, okay. Now, because I'm dealing with a projector here, it might make sense. There's actually a projector mode if you want it graphed a little more dark, and that tool thing is right here. This tool thing allows you to change from Cartesian to polar coordinates. We haven't talked about polar coordinates yet. We will. Okay, but it also allows you to have this button right here that says projector mode. You can switch back and forth between degrees and radians and things like that, which we might want to do for the next one. But right now I want it to be in projector mode. Okay? Now, I want to know what's the limit as x tends to 0 of 1 over x squared. Okay? So on my graph, what do I need to look for to evaluate that limit? In order to see what the limit as x tends to 0 is of 1 over x squared, what do I look for on my graph?
What the height is at 0.
That's right. You're going to look for what the height is at the x value of 0. Okay? So my next question is, what's the height approaching at the x value of 0?
Well, I'm not sure.
I'm not sure either, because it looks like it's going like that. At x equals 0. Maybe I'm just not zoomed out enough. Maybe I need to view higher values on my y-axis. Okay, over here on Desmos, there's a little zoom out key.
It's still going.
Yeah, it's still going.
Is it infinity?
Very good. That thing equals infinity. Tickle.
Don't you hate that? No words.
All right. Now, the graph approaching infinity is one time when some people say the limit does not exist then at that x value. We won't always say that, but we'll say that for today. If the graph approaches the same type of infinity, so if it goes to positive infinity on both sides or negative infinity on both sides, then the graph can actually equal, the limit can actually equal infinity. But your book for right now says that that means the limit does not exist. So that is case 2 of when the limit does not exist. If the graph approaches infinity, then the limit does not exist for right now. If it approaches 2 different kinds of infinity, like left and right, it goes to 2 different things, then the limit does not exist anyway. All right. So you can put DNE over there instead of an infinity symbol. Let's do another one. If I can. Let's do another one. By the way, the one we just worked through a minute ago, to type absolute value into Desmos, you go ABS parentheses X. This one could be some of your favorite. I want to know what's the limit as x tends to 0 of sine of 1 over x. Okay, so what you're going to do is you're going to graph sine of 1 over x. I already graphed it for you. Desmos also allows you to turn off graphs, so mine is right here. Can you see that?
Yeah.
What's it doing?
Like compressed sine.
It's like, okay, here's what it's doing. It's going like this, sine of 1 over x. It goes like that, and then it just goes, and then it goes up and back down.
So it's like sine.
It's oscillating. If I want to know what's the limit as x tends to 0, you tell me, what's the limit as x tends to 0?
Well, it's because it's positive and negative. Does that mean that?
This thing is oscillating between 1 and negative 1. Therefore, the limit does not exist.